Good morning, everyone. Hello, everyone out there, all of our participants on our YouTube channel, on AWS UserGroup Data, as well as UserGroup India. How are you folks doing today? I know it's quite hot summer out whichever part of the world you are, either you in India, Bangalore, Pune, Mumbai, right? I know the temperature is a bit loud here. So thank you so much for joining on Saturday morning. I know this is a bit of vacation time, so not a pretty easy one for you guys to wake up in the morning. And that's what I was chatting with my co-speaker also. What time you wake up, how do you wrap your day and all. So absolutely we'll have such kinds of fun talk at the end of the session when we go to the networking. But thank you so much for joining today. I really appreciate it. This is our first inauguration session about AWS User Group Data India, and we have a wonderful speaker along with us and as well as with me to talk about why are we doing all of this, how exactly we are going to work, how you can follow us, so on and so forth. So with that, let me kickstart today's session and let me take you through these next steps, right? So as you all know, this is going to be our inauguration session. From a speaker standpoint, we'll have Darshil Parmar with us soon, as well as with me. We'll both talk about, I'll cover up why and what is the whole motivation of doing this entire AWS user group data. And Darshil will talk about the basics of AWS and data. So in case if you are for the first time in such kinds of user groups, you get to know of why exactly user groups and what is AWS all about. And this session, if you're watching in the recording mode, please don't hesitate to post your question in the chat. I'll make sure Darshil and I'll answer all of your questions after the sessions. With that, let me quick start with our first thing. If this is your first session about it and you don't know about AWS User Group, so let me give you a quick context about AWS User Group. AWS User Group are peer-to-peer communities, like-minded people who want to evangelize, talk about AWS User Group, their experiences working on AWS. I've seen a lot of real stories where people have been participating in these different user groups, how their career has changed. They have shifted from the traditional job, support jobs to testers and those kinds of stuff to DevOps or data, learn a lot from networking. And there are many other stories which I can easily talk about in my free times that how exactly user groups have changed your world. And one of the examples sitting in front of you guys that how exactly things have changed for me personally and how we have learned and network all of this. We have 27 plus. I'm pretty sure this is one of the other one user groups. So there are 27 plus in India and Southeast Asia. So things like you talk about Mumbai, Bangalore, Delhi, Pune, Kolkata. There are many other user groups you have. So please search on AWS user groups on Google and join your nearby user group today. In case if you don't find a nearby user group, please DM me on LinkedIn. I'll help you in touch with this. As well as if you want to contribute to your user group, do reach out to their leads, join the different meetup channels of user group, and attend the sessions today. A couple of glimpses of different user groups. What we have done recently, we have done a AWS User Group Community Day in Mumbai, which happened on April of 6th. And there are a lot of different kinds of event that takes place across India, I would say, not just India, across the world. So in case if you are an international audience, don't hesitate. There are different user groups, community days, India summits, those kinds of different developer events keep happening in bits and pieces in different part of the world. So please make sure you attend those kinds of different events and gather as much learning as possible. With that, let me talk about why exactly we started all of this entire user groups, right? The whole idea of starting the user group is to make sure that there is a proper knowledge sharing, learning, expertise. There is a networking event around it, and people can learn and upgrade themselves, right? This is all we started around it. This is no fees kind of thing that you have to pay to get into this. No, this is completely free, done on to motivate the learning, the knowledge sharing, and peer-to-peer community, right? For the community, by the community kind of thing. Like if I need to learn something maybe on the machine learning, so I post the question in the chat, hey, anyone out here knows about machine learning model, or maybe generative AI, which is the new thing. Or if someone wants to learn about data, they can post a question to me. This is how you build the networking and get more learning from the people around the network, right? So that is the whole motivation. And absolutely, as a part of it, you get different rewards, swags to show off a bit and show that how exactly are you contributing and evangelizing within the community. So that's the whole motivation of that one. And with that, we started a new user group which is the first session we have today, is AWS User Group Data India. People around me who've been knowing me from years know how I am more evangelizing for the data. And that's how I thought of that data is the core central play of anything and everything what you do. Whether you're working as a software engineer, whether you're working as a DevOps, you're working as a machine learning, generative AI, data, anything of it. Data in some form, some shape has become a part and parcel of our life. And that's why it's become very important that with this new age of technologies and evolving things like generative AI and machine learning and stuff around it, it's very important that we stuck to foundation and more start driving our data to become that central play and by leveraging machine learning on top of it. So that's where I thought of let's start something where we make sure that foundationally we also grow along with new techniques and tools out in the market. And that's how, with help of AWS developer marketing team, we got and launched AWS User Group Data to make sure with this evolving technology out in the market, we also upgrade ourselves not only on those new technologies, but as well as the backend things and stuff which are the driving of these new technologies. Let's also understand how those things work around. So if you have not joined our AWS User Group Data yet and still waiting for my motivation, then don't worry. I have already put a barcode here in the chat. So please scan the barcode. We already have 3 channels today to follow us on Meetup, on LinkedIn, as well as on the WhatsApp. I'm going to post all the 3 links in the chat as well as in the YouTube comment section. So if you're watching it offline, I would request you, please do join. I can assure you, we are not going to spam you, but there's going to be a lot of learning and interesting fun for you guys. So don't wait, join right now and explore your learning and evolve with us. So as I mentioned, LinkedIn, WhatsApp, Meetup, I'll share all of this with you guys in the comment of this video as well as on the channel, right? So don't hesitate, do join us, and as well as please stay tuned. I'm going to pass it on to Darshil now, but please stay tuned. I do have some surprising on our next steps. I'm pretty sure you're going to like it. So stay tuned with us. And with that, let me stop sharing my screen and let me invite Darshil on the stage. Before I get Darshil out here on the stage, I'm sure most of the people know who's Darshil. Just in case if you are for the first time, you don't know about Darshil, let me give you one line. He has a millions plus follower on the YouTube, a big data evangelizer. He is currently focused to building data vidya and based out of Mumbai. I think most of the folks who attended Community Day Mumbai also got a chance to meet him in person. And if you have missed out, don't worry. We'll also have in-person session soon where we'll have Darshil with us. And also Darshil is going to be the co-organizer for this entire user group. So with that, let me invite Darshil to talk about it. I'm sure I'm not going to meet his expectation cards, what he is good with it. So not to waste a minute and let me get Darshil out here. Hey Darshil, how are you doing today?
Let me check. Yeah, I'm doing good. How are you? Good morning.
Doing great. Thank you so much for. I know it's not easy to get your availability for the call. So thank you so much for joining us today and explaining and giving your knowledge sharing for all of our participants.
Yeah, that's my pleasure. Yeah, thank you for inviting.
Absolutely. So with that, I'll take a back seat. I don't want to bore more audience and pass it on to you. Let me bring your screen and best of luck. I'll go in the back end.
Yeah, thank you so much. So, hi everyone. Good morning. My name is Darshil. Okay, and today we'll be talking about data engineering on AWS. Okay, so let me just move forward, and I'll start by me so that you understand why I'm talking about all of this and what I've been doing till now in the last 5 years. So I started my career as a web developer. I was in college at that time in the Mumbai only, and I was working on a LAMP stack, which was PHP, MySQL, HTML, and CSS. Then around 2018, I saw like good hype around data science and machine learning, and I thought, let's try learning about data and what are the different elements attached to it. So I started learning from Coursera courses. I enrolled onto bunch of Udemy courses, YouTube, everywhere. I started learning about the data part. Something happened and I got an internship at a mid-sized startup firm, where they hired me as a data scientist, but I was working mainly around data engineering. So I got a lot of projects around data engineering. I started working on the cloud computing platforms, building ETL pipelines and stuff like that. That same company gave me the full-time opportunity, and this company was around consulting based firm, so they used to give the services to the US based organization in Europe. I used that knowledge and experience to do my own stuff. So I worked at a job for a year. I learned a lot of things. Like in 1 year, I was working on multiple projects. I led teams of people to deliver large scale projects. And with the knowledge that I learned, I started doing freelancing. So I quit my job after a year and I went to become a full time freelancer as a data engineer. Worked as a freelancer for 2 to 3 years, and while I was doing freelancing, I got a remote job, or you can say the contract based opportunity at a Wayfair. Wayfair is like the furniture company in Europe and US. You can consider like the Amazon, but especially like focused on the furniture. Worked there for 3 years, worked on multiple projects around like data engineering, building data models, migration of the data, writing SQL scripts, a lot of things. And while I was doing all of this, I understood that having a personal brand is important if I want to sustain the freelance business or just grow as my individual brand. So I started teaching about the data engineering on YouTube, because when I started my career in data engineering, I had to refer multiple resources. Like I'll read a blog, I'll read a book, I'll go to some website to learn about specific things. And there were very few people who are talking about core of data engineering. These days, if you go on YouTube, you will find bunch of people talking about this field. But when I started, I had like no one who was talking about all of these things. So I started creating content around data engineering. I started talking about that. Took me 2 years, and I recently crossed 100K subscribers on YouTube. We'll talk about that at the end of the presentation. And then I started building my own platform called the Data Vidya. This goal of the platform is to help data engineers, or in general data people, to prepare for the interview, help them skill up for the data engineering so that they can get a job and grow in the future. Okay, so this is all about me, and we'll talk about everything after end of the session. But I want to mainly focus on the today's agenda and what we are going to discuss, right? As this is the first session, I want to go from the basics, give you introduction about the data engineering on AWS, and then I'll show you basic demo on how you can create a pipeline, data pipeline on AWS using the bunch of services, right? So this is the agenda. We'll understand the basics of fundamentals of data engineering on AWS, and demo. If I go fast, just let me know on the comment section so that I can slow down. My natural speaking pace is quite fast. So things that take people like 1 hour, I can explain it in half an hour, because I usually speak fast. So let me know if I'm going too fast. So I'll slow it down. Okay. So let's start with this fundamentals of data engineering, because a lot of people understand the tools and the technologies, but the fundamentals, right? They don't change for like 10 to 20 years. Fundamentals remain the same, right? Even if you learn the new coding language or programming language, you know that on the base we have like C or C++. These are the core computer science fundamentals, like databases, computer networks, operating system. All of these are the core fundamentals that do not change. Everything else is a wrapper on top of all of these technologies. So fundamentals of data engineering, understanding fundamentals, is that only that even the new tools come in the market, the fundamentals remains the same, right? It will not change for the longer period of time. So we will start from the fundamentals. We will understand what are the different things attached to it, and then we'll move forward to understand different technologies and the projects part that we can use, right? So we'll start with the business, right? Because understand, right? In technology, especially talking about data field, right? uh, Everything is around business only, because at the end, you are using data, you are building everything so that companies can generate profit, understand the customer behavior, and improve the overall product and services. So business can be anything. It can be Amazon. The business of Amazon is to recommend the good products, sell products online, understand what the customer wants. So if you go on Amazon, when you buy a product, and when you see like people purchase this, also purchase this kind of like the use of data, understanding what customers are buying, and also recommending extra product to them, so that Amazon improves the overall user experience but also increase the profit, right? So this is the business of Amazon. Same goes with the Netflix. They recommend you good TV shows to watch. They keep engaging you again and again so that you don't leave the platform. We have the Instagram and we have the Zomato, right? all of these companies are business, and the goal of business is to understand their customers and improve the product. So again, making data driven decision, these are the business goals, right? You can't make the decisions based on the assumption. You need to have like proper understanding about what is happening in the business, and then you take the decision. Then we have the improving customer engagement. Again, when customers comes to your product, you need to retain them for the longer period of time. It can be like sometimes people come and leave the website, but what you really need to do once they come, you need to have like strategies so that they can retain and they can keep coming back on the same platform. So you keep opening Instagram again and again. Oh, why does that happen? Because Instagram has understood, based on your data and your pattern, that how you interact with the application. So they try to keep, you might see, right, the reel section keeps getting updated because they want to keep that button on the right place at the right time, so that whenever you come on the website or on the application, you are likely to click on that tab and go onto the reel section. Like that, even if you are just scrolling the field, they'll trap you out and they'll put you in the reel section, uh, because they want to engage you for the longer period of time. Then again, enhancing the operational efficiency, even the e-commerce business, right? We have like a lot of different things: suppliers, return order, shipping of the orders, the first mile, second mile, the delivery side, right? A lot of people, this takes like a lot of effort to understand what is happening into the each and every segment. So using data, you can understand where we are lacking, what are the bottlenecks, and then you can improve that part of the business to improve the overall business. Then we have the revenue growth. Pretty simple, right? You want to increase your revenue, and all of this comes from understanding what the customers are doing. You can also identify the new market opportunities based on the customer behavior. You understand like this product is getting a lot of engagement at this particular time of the month, so we can tap onto that market and try to market it more. Then we have the key performance indicator, again understanding what are the key metrics that drives our business. So these are the business goals, completely dependent on the data. And this is what it looks like, right? You have the application, and then at the end, on the business side, it can be the dashboards, it can be the machine learning models or the AI models, and in between you have a lot of people, the actual people doing the work, which is a data engineers, data scientists, analysts, trying to make sense out of data. So we'll be understanding this middle part, which is the mainly the data engineering. Okay, these are the people who build the application, the software engineers who writes the code and builds the application. These are the people, can be business analysts, data analysts, machine learning engineers, who use the data to derive the final outcome and generate value for the businesses. And these are the middleman who make sure that all of this data that flows from this source, okay, again, data comes from multiple sources that we will understand, needs to be into the structured format so that you can feed it to the machine learning models, or you can visualize. You can't visualize the garbage data. You need to have a proper structured data in order to do the final visualization or train a machine learning model. So if you have the basics about machine learning, it's like garbage in, garbage out, right? If you feed the bad data to the machine learning model, it will give you the bad output. So the entire use case of this pipeline is to make sure the data that flows through this application to this model is in the proper structure format, and only the good data that goes. It's kind of like the plumber, right? You are a pipe, you're building a pipeline of the water pipeline, and you're making sure only the good water goes through this source and all of the bad waters comes out of the other source, something like that. So this is what we'll be understanding. And to understand that, we'll go with the data engineering life cycle. This is from the fundamentals of data engineering book. If you want to understand about the data engineering, you can definitely read that book. This is a data engineering life cycle that talks about every single component of data engineering project, right? From data generation, ingestion, transformation, serving, storage. So this is like the generation layer, and this is the transformation layer, and this is the serving layer. And then there are some undercurrents that impacts the overall data engineering project. So we'll understand this one by one. First is the data generation. Now, the generation of the data comes from multiple places, right? uh, if we were to talk about like some of the sources, we have the applications, mobile applications, we have the sensor data, right? In the e-commerce business, this happens a lot, right? When a truck is moving from one source to another source, there might be sensors attached to the trucks to understand how truck is moving, which route that the truck took, in which data warehouse the truck went into. All of these things are like data generation sources. So we have the web analytics, Google Analytics, data comes from there, sensors, stock market data. These are the sources where the data gets generated on the first place. This is really important to understand because a lot of people who get into the data field don't have understanding about where the data is coming from. They can build a machine learning models, they can do the transformation, all of this stuff, but having understanding of how data is generated will make you a better engineer because you understand the entire pipeline. And one of the uh, main source of data is usually the RDBMS and the third party APIs, right? You integrate all of this data from the third party API and try to get it on your platform. So this is a generation source. Then once we know that okay, data is coming from these multiple sources, what you need to do, you need to ingest this data to a system. And there are multiple ingestion strategies. Ingestion basically means you try to extract the data from all of these different sources and you put it onto some storage location. This is considered as a landing zone where you get the raw data as from the source and you directly put it, that raw data, onto the storage. Now, the storage location in AWS case that we will understand as we move forward is called as the S3, the simple storage service, where you can store any type of data that you want. For ingestion, you can use multiple services, like it can be compute service like AWS Lambda, or you can use Apache Kafka, which is an open source service, also available on AWS like managed environment. So you can ingest the data, you can store the data onto the storage. Then comes the part of the transformation. Now, this transformation usually means you try to clean the data as per the business requirement. It can be adding new columns, it can be dropping new columns. Again, data is coming from the multiple sources. So in one source we might have the date time format as YYMMDD, but in another source the date time format might be DDMMYY. Okay, so you need to like structure this data onto the single format so that you can give it to the other person, which is a serving layer, like for the analysis or the building machine learning model. So transformation is usually dependent on what the businesses want. So we are going to let's consider we are going to give this data to a data scientist, and data scientist comes to us and asks us, okay, I need these columns into these formats, okay, and I need to aggregate this data onto, let's say, ID level or the region level. So as a data engineer, you will write all of this transformation code. Either you can use the code or you can use the drag and drop environment. Tools are different. You write the transformation and you serve this data to a user. Now serving also comes to, you can store it into the storage location, or you can use the data warehouse, you can use any third party tool that you want, right? Serving comes from here. And once the data is hosted onto the data warehouse, so in AWS case it is AWS Redshift. So once you load your data onto that, business analysts, machine learning engineers can use this data to build a machine learning models, analyze that data and move forward. There's also one more thing called as a reverse ETL. So that basically means once you transform and serve your data, you can use that again, clean data, and put it back into the system, okay, to get more insights out of it. So a little bit advanced stuff, but this is the core of data engineering lifecycle. Now, these are the undercurrents. Undercurrents basically means the things that powers its entire life cycle. So first of all, we need the data security because this is important, right? You can't just share data just like that. There are like confidential information such as credit card numbers, the user phone number, address, and everything. You need to make sure all of these data are properly secured. Data management is basically means, again, you have like data coming from multiple sources. How do you manage all of this data? If your company grows, the data tables will also grow. So you will have like hundreds of tables. How do you manage? How do you keep the catalog of the data? This is also important part. Then data ops basically means if you make any this is kind of like the DevOps, if you understand, like in the DevOps, it's kind of like the philosophy where you try to organize everything into a proper pattern. So if anyone makes changes to a code, it should go through a step-by-step process in order for that code to be pushed into the production pipeline. So this same philosophy applies here, where if you make any changes to your transformation code or the data generation pipeline, this will go through a step-by-step process for that to be applied onto the final outcome. Then we have the data architecture. We'll talk about this data architecture part, which is basically a blueprint of how your data system looks like. Orchestration, this is the step-by-step approach how you execute your data. So extract data from this source, then do this transformation, then apply this transformation. So orchestration basically means step by step execution, and the software engineering. This is the building blocks of every technology, right? You engineer your data pipeline. Is This is a data system, right? So you're building the entire platform using multiple services and building a product at the end. So software engineering philosophies also applies on top of this. Now, the data generation that we already talked about, right? Data comes from the multiple sources. We have the web application, RDBMS, sensors, and web analytics, surveys, API. So these are where the data are coming from. As you can see, right? We have multiple places of data. Now, the growth of data is insane. If you want to process this huge volume of data, you need systems that can store, process, and then also like serve this data to multiple users. So this point is very critical to understand where the data is coming from. Then this is what the data storage looks like from the application end, right? You have the user's application. There might be some client libraries. It can be like Node.js. It can be a backend application like Java, Spring Boot, or PHP, or whatever the company is using. That will connect to the RDBMS server, and then that will store the data onto the actual databases. So this is what the data storage looks like from the data generation point of view. Now this is the database management system where the data actually gets stored. Okay, so there are multiple open source tools available, such as PostgreSQL, Oracle, SQL Server, MySQL. Depending on the requirement, company chooses one and then move forward with it. On AWS also, you have the RDS that also supports all of this system. uh, you can use that and load your data easily and scale it as per your need. And this is what the SQL queries looks like if you're watching this video, that means you have the basic understanding of data. So I understand you might be familiar with the SQL, structured query language. SQL is the way we communicate with the databases. So as per your requirement, you write the SQL queries and get the outcome that you want. You can manipulate data, you can delete something, insert some records using SQL. Now these are the data processing system. So the database management, DBMS, that we talked about was considered as a OLTP, online transactional processing. These databases are good for like faster read write updates. You have the CURD operation like create, update, read and delete. These databases are really good for that. But if you were to analyze, like, last 5 years of data, uh, the OLTP system will not be able to do that. The reason is that these data are actually stored as a complete row-based format. So when you try to scan the one single column, what it will do, it will scan the entire row individually, and then it will pick one single column to give you the final output. But we have something called as a OLAP system, online analytical processing. That basically means the data are usually stored inside the columnar format. So in analysis side, we usually need like 2 to 3 columns to get the final analytics. So we might have the product information and the revenue information. So if you want to find like the total revenue by the individual products, you just need the 2 columns. You don't need other columns. So in this case, if you want to answer like how many people bought X product on the XYZ month, you can easily do that using OLAP system. But if you were to do the same operation onto the OLTP system, which is using PostgreSQL or MySQL, it will take a lot of time and is not efficient to write all of these queries onto the system. So basically, in data engineering, what we are really doing is that we are taking data from OLTP system or the multiple sources and trying to put that onto some kind of target location. It can be OLAP or the storage system. So this is the backbone of the data engineering where we are doing this. And to do this, we have something called as the ETL, extract, transform, load. Okay, where we extract data from the multiple sources, databases, files, SaaS application, all of these places. Then we have the staging area where we store the data that we understood in the data engineering life cycle, and then we load our data onto data warehouse, and this data can be analyzed. So this is what the entire ETL process looks like. Now these were the fundamentals. Now what if you were to do this using the different tools? We have these many tools available for to perform these entire operations, right? You can't even see the tools name, but if you just try to recognize like individual, you will see the AWS over here. You have the Oracle for the data warehouses, Snowflake is available over here, Databricks is here. A lot of tools. You can just Google about like the big data landscape 2024. You will get this image, and then you can zoom it and try to see what are the different applications or the products that powers this entire pipeline, right? This is the entire landscape for the data, right? Which is machine learning, AI, data landscape completely. So If you want to understand, like if you want to use the like specific tool for infrastructure, we have these many tools available. For analytics, we have these many tools available. Most of the tools, like you're not going to use every single tools. Usually depending on the requirement, you try to pick up the individual tools. So uh, yeah, so basically based on the requirement and the architecture, you pick the final tools and build your pipeline. Now while we're talking about AWS, we'll be focusing on just using AWS products rather than using every single products available in the market, because you can build a complete data engineering lifecycle or the data engineering project on AWS. Top companies like Netflix, even Airbnb, Dream 11, which is like last year powered the IPL and they sponsored the IPL, uses AWS to process all of the data on the large scale. So uh, big players usually use AWS to process this, and these are all of the services available. Now again, when you go to a cloud platform, you will see cloud is fundamentally built on the multiple services. We have the infrastructure as a services, where they provide the actual infrastructure. It can be like EC2 machine or any compute machine. We have the software as a services, where they provide you some of the software that you can use in your product. Or we have the platform as a services, where you don't have to worry about like management of the environment and everything. They give you everything on the AWS. You just worry about writing your code or building your pipeline. So hundreds of services available on AWS. But as a data engineer, you just need to know 10 to 20 services, okay, that you will use. So the Pareto principle also applies here. Like in order to do the data engineering work, the 80% of the data engineering work, you just need to know the 20% of the service, right? So this is what we'll be using, and we'll be understanding some of the highly used AWS services that required for the data engineering. This keeps changing, but there are some fundamental services that you'll mostly use, and these are the services. Number one is S3, simple storage service. Again, it is the object storage. Uh, where you can store any types of file that you want: CSV, audio, video, Parquet file. Usually S3 is used to build a data lake. So if you want to do the data backups, if you want to store the static website file, media files, any type of files that you want, you can store it on Amazon S3. And we will understand this when we actually do the demo. Then we have the AWS Lambda. Lambda is basically the serverless compute service. So usually when you want to run any code, you have to create the backend infrastructure for that. But using AWS Lambda, you don't have to worry about all of this. All you do, you just focus on writing your code. AWS will automatically scale up and scale down your servers and directly give you the outcome. So most of the worry about the infrastructure part and the building of clusters and everything goes away. Then we also have the AWS CloudWatch log. Now, what is happening in your data pipeline, right? What are the logs? How did we do? Why did this pipeline fail? All of these things can be easily monitored onto the CloudWatch logs. These are the services on the Glue side. We have the AWS data crawler on the Glue crawler. That basically means once you store your data onto AWS S3, right? And if you want to understand what type of data this file contains, it can be like how many columns it has, the schema of that file, the information about the overall file. You can run a crawler on top of it, and we'll do this in our demo section, where it uh, it will automatically crawl your data source, identify the data formats, and infer schema to create a data catalog. Data catalog basically means the information about your data, which where you can store such as information about like this is the column and this column does this and with this data type. So crawler will do that job automatically for you. Then we have the data catalog. uh, Once you build a crawler, it will automatically build a data catalog, which is the metadata repository about your data. So again, that we talked about, right? What type of data it contains, how many columns it has, and data types. And you can use this catalog to query using Amazon Athena, which is the interactive query service, where you want to directly write SQL queries on top of your existing file. So let's say if you have the CSV file stored in your Amazon S3, you can directly write SQL queries on top of that file system using Amazon Athena. And again, we'll do this in our demo section. Okay. Then these are the other services, such as for the data warehouse, we have the Amazon Redshift available. The thing that we talked about, the OLAP, right? The system that are specially built for query analysis. Using You can use Amazon Redshift this is a managed database service that provides you to analyze your data on large scale. Then if you want to process like billions and trillions of data, right? EMR is a big data processing service. So either you have like your data onto on premises, and if you want to migrate your Hadoop and the Spark jobs, you can easily do that on EMR. Or if you want to write something from the scratch, EMR is basically the center of big data processing if you want to process the large scale of data. And then we have the Amazon Kinesis. So again, you see all of these applications like Uber, Google Maps. How do they process the real time data? This is the service that you can use to process your data into the real time. And the use case of real time is basically if you want to get notification quickly. So whenever you order anything on Amazon, you get the order notification when it gets shipped, when it got returned. All of these information are sent to you in the real time manner. So just like also you, when you order something from the Zomato, right, you get each and every information delivered to you in the real time basis. So services like Amazon Kinesis or Kafka can help you achieve this outcome. Then we have the migration service, again, data migration service. When I started my career in data engineering, I used to work on a lot of migration projects. Migration projects are very common because a lot of companies are still on to on-premise network, and they want to migrate their data onto the cloud platform so that they can scale easily, they can manage them properly, rather than having to increase the RAM, hardware, everything by themselves. They can just rent all of these things from the cloud provider. So DMS is a core service where without a downtime, right? Usually, when you want to migrate any data, there needs to be a downtime. You can move your data from one source to another source. Then we have the Amazon RDS. Consider RDS as your relational database system, which basically means if you have, let's say, if you are migrating from PostgreSQL from on-premise to the cloud PostgreSQL, RDS will give you the exact PostgreSQL available on the cloud platform. It also has like MariaDB, Oracle, SQL servers. So as per your requirement, you can choose a provider like the databases, and you can build your application. Then we also have the Amazon DynamoDB. Again, this is the NoSQL based document database. So if you want to build a, again, serverless, if you want to build a application that has the requirement of document database and the NoSQL, you can use DynamoDB over here. So lot of services, I mean, if I were to go, it will take a lot of time, but these are the core services that we talked about, right? There is a service for the collection of data, there is a services for the storage of the data, there are services for the processing of the data and analysis and visualize. Like Amazon QuickSight is for the dashboarding. There are some other services such as IAM, KMS if you want to secure the data. If you want to process data, we have the Glue, EMR, Lambda. You can use lake formation. To analyze the data, we have the Athena, Redshift, Kinesis Analytics. To store the data, we have the S3, DynamoDB, Elastic Cache, and the collection of data that we understood. So a lot of services, but these are the core building blocks of the data engineering services. And using these individual services, you can build your entire data engineering pipeline, right? So this is the architecture of the Dream 11, and they use AWS to process and store their data. So over here you will see, right, there are some open source services, but on top of that they are hosted completely on AWS, so that just a second, yeah. So that you can easily build your application and the data system. So as you can see, they have data coming from multiple pipeline, the sources. uh, if you were to see the data engineering lifecycle that we talked about, right? This is the fundamental system again, using the tools. So again, data generation part, these are the data generation part. This is the data ingestion part where they are using Kafka to ingest this data. Then this data gets stored onto S3, which is the data storage. On top of that, we have the transformation layer, which is the ETL available over here. Amazon Athena is to do some queries on top of this data. Redshift to analyze this data, and stream data to Apache Flink and KSQL to process the real-time data. And then there are some other notification service and the third-party service that they are using, right? So this is the core architecture of Dream 11, and this is how they use. Quite complicated, and this is the reason I included this, because fundamental is still the same, right? Even if you go onto the like complex to complex architecture, you will understand that the fundamentals of data engineering lifecycle stays the same. Tools will come and go. You can plug any tool and put it over here. So instead of this Apache Flink, you can put the Kinesis. Instead of let's say Apache Spark, you can put the EMR, which is the managed version of Apache Spark. A lot of different things as per your requirement you can put and build your application. So this is the architecture, and what we'll do, we will do a quick demo onto this kind of architecture where we will build this, which is basically we will have our data stored onto Amazon S3, which is the raw data. Very simple pipeline, not complicated. We will trigger the AWS Lambda function, where what it will do, we will upload the JSON data and we will convert that JSON data back to a CSV format. Then we will crawl our data using AWS Glue, build a catalog, and analyze the data using Amazon Athena. So this is the basic architecture diagram that we will try to execute. Very simple, not that complicated. But the goal of this demo is to help you understand how do you connect these services together to make to build a final data engineering project, right? I have a lot of free projects available on my YouTube channel also, which are more complicated, but as you are just starting with the data engineering, you might not have understanding about it. This is the good place to start, where you understand how to build a basic data pipeline. So I'll just go to my AWS console. Okay, so in this, first we have the s3 bucket. So what I'll do, this is the AWS console. This is what it looks like if you are just seeing it for the first time, uh, where you will find all of the services available here, based on the categories. You can also search it, you can also open this. Okay, and these are the recently visited. So if I open the EC2, you will see like I have like some of the EC2 instance running for my website. And if I just write S3 on top of this is the scalable storage in cloud. I click onto S3. This is where I can create the buckets and store all of my files. So you can see all of these are my S3 buckets available over here. Again, this is for my previous work. Some of them are for the log, some of them are for my actual work. What we will do, we will create the basic S3 bucket. I'll just write, let's say, AWS UG demo pipeline, something like this. Let me just store this somewhere so I don't forget it. Yeah. Okay, you give the name of the S3 bucket. If you have the existing bucket that you want to copy the settings from, you can do that. These are the ownership. So if you want to have the access control list enabled, which is kind of like the security measures that you want to put, you can also add that. Blocking public access, I don't want anyone to access this bucket from outside AWS. Versioning is basically whatever you do onto the S3 bucket, you can keep the versions of it. So when you delete something, it will uh, when you create like multiple versions of files, when you delete something, replace something, it will track each and every version of that file. Then this is the encryption, the bucket case, all of these are the default setting that we don't want to mess with. And we just create the bucket, pretty simple, right? What I'll do, I'll just search here AWS dash UG, and this is my uh, demo pipeline. Yeah, this is the uh, actual bucket. Now in this, what I'll do, I'll just give me a second. Yeah, in this, what I'll do, I'll just create the two folders. One is the raw JSON data. Okay, this is where I'll store my raw JSON data. This is kind of like the landing zone. So whenever I get the data from RDMS system or the third party API, this is where my all of this data will get stored. And second data is that I will see the CSV data. So the CSV raw data. Okay, because what we are doing is that we are converting our JSON data to the CSV data using AWS Lambda. So this is my raw data and this is my CSV. So our folder structure is ready, right? The S3 bucket that we want to store our data, which is raw data, and the transform data is ready. Now what I want is I want to have the Lambda integrated between this. So all you have to do is just open AWS Lambda, open it onto the new tab. Okay, here again, if you are seeing it for the first time, Lambda, this is what it looks like. Serverless compute service, where you can uh, write all of the code and don't worry about the final infrastructure. All you have to do is click onto the create application. I'll start from the scratch. They also have the blueprint available. So if you want to, get object from the S3, make HTTP request, all of these are the predefined templates. You can also use the Docker image if you want that. So I'll go with the scratch. I'll just give the name as AWS UG Lambda demo. Okay. Runtime, I'll go with the Python. Everything else is fine. Execution role, this is where you apply the IAM role, where it needs to have the permission to read data from Amazon S3, uh, and also read and write data from Amazon S3 and the Lambda permission. I already have the role created for this, which is, I think, wait, let me check. Yeah, I think it is this one. I already created for one of the projects, so I'll go with that. uh, so this will, once you create this will create your Lambda function here where you can write the code. Here you can add the triggers. So Lambda works on the multiple triggers. So for example, whenever we upload any data onto Amazon S3, this Lambda function code should run. Or whenever you delete any data, or at 9 a.m., this Lambda function should run. So all of these kind of triggers that you can apply onto the Lambda function. Here what we will do, I already have the code written, so I'll just put it over here, and then I'll make the few changes as per our requirement. Okay, so this is the basic Python. Again, if you don't know Python, I'll just try to explain you from the basics. But uh, you need to know one programming language. It can be Python, it can be it can be Python, it can be anything. Node.js that AWS Lambda supports. But all we are doing here is that instead of this, first we will hard code this, right? So first of all, I need to write my bucket name where my files are actually stored. So in this case, it is stored onto this. Let me zoom this so that you can also see. Yeah, this should look good now. Okay. So this is where my bucket name is. This is where my files is stored. Then I need to provide the JSON key. JSON key is the actual path where my file is actually stored. So in this case, it is stored onto the raw JSON, and I'll upload one JSON file onto this. I'll do the add files. What I just did is that I'll just show it again. I went into the folder, which is the raw JSON. I clicked on the upload. I click onto the add files. You can also drag and drop. And this is the online retail JSON file available, right? I'll just upload it and I'll upload it over here. If I were to show you this JSON file, let me see if I can open this. Yeah, this is opening on the Firefox. Wait, I open it here. Yeah. So this is the JSON file. Where did it go? Wait. It's here. Yeah. And this JSON file is a big, small JSON file, which is the online retail JSON file, where you have the invoice number, stock code, description, quantity, invoice date, unit price, customer ID, country. So you understand the JSON format. It is in the bracket, the key name and the value name. What I want to do, I want to convert this JSON data into the CSV file. So I'll do that now. I'll go to this. Okay. I uploaded this data onto the raw JSON format. What I'll do, I'll go here and I'll put the key name, which is I'll copy the S3 URI, then put it over here, raw JSON. Okay, slash, I give the name to the file. So again, format is same. You have your bucket name and you provide your key name. Once you do that, this is the S3 object where you can get we created the, using the Boto3. Boto3 is a library that you can use to interact with the AWS services. So using Boto3, I connected with the S3. Using the S3 get object, I added the bucket name and the file name. I read the actual body using uh, the data that I wanted to read from the JSON file. Using the pandas data frame, I read the JSON file, converted that into the string buffer, and again wrote that back to the S3 bucket. Again, basics of Python, if you have understanding about this, these are the basic function that we're using to read the data and write data. This is a timestamp format that I'm attaching while writing this data. So I want to write this data onto CSV raw data, which is this one. So I'll put the folder name, which is CSV raw data slash online retail, and I'm attaching a timestamp. So every time we write the data, we need to attach one timestamp so that we can understand when this data was written. And we use the put object function. This is the get object function to get the data. This is the put object function. Bucket name, CSV keys, we provide the value, and then we return the code whether this was success or not. Right now, all you have to do is click onto the deploy button. This will deploy this entire code uh, onto the AWS, and I can just test this. So I'll just give the basic name as test and I'll just click onto the save. Right. If I test it, you'll see we are getting the error as no module as pandas, because what we are doing is that we are importing the pandas module to read the CSV and the write CSV, but we don't have the module available. And for that, we have the Lambda layers available where you can have the external packages to run your code. So over here you will see like these are the lambda layers available. You can also upload your own lambda layers, but as you can see AWS SDK pandas support, so I can just use this pandas uh, layer. That basically means it will attach the pandas to this lambda function. So whenever we run this, it will automatically import the pandas from there. I'll just do the test and let's see what the error that do we get. So it's currently executing. Now it is giving me error message as task timed out after 3 seconds, right? That basically means the default configuration of lambda function, if I go here, you will see the timeout is around 3 seconds. So lambda function will execute for the 3 seconds, and if the code is executed completely, it will give you the output. If not, it will give you the error that we ran out of time. You need to increase the time if the code takes long. So I'll just change the timeout to the 5 minutes, 5 minutes 3 seconds, okay. And I also increase the memory because we might run out of the memory. So I'll just give the 1024 memory, which is the RAM, to execute the code, and I'll do the save. And what I'll do, I'll again go back to my code and I'll do the test. Okay, let's wait for this to execute. If we face any error, we'll try to fix it. If we don't, we should be seeing one file available onto this part. So calling the invoke API function failed, the error cannot be occurred. I think, wait, let me check again what this error is. Let's wait. Mm. It's taking 22 seconds. So again, the default value was around 3 seconds. Now it might take around 1 minute in total because we have a lot of things to do here. Where it is reading the data, it is actually processing this data, then writing it onto the S3 back. So 40 seconds. Let's wait. We can also track it here if we have any files. We don't have any files, so let's see how much time it takes. Mhm. Till now, if you have any questions, you can always ask it on the live chat, so I'll try to answer it. If you have any questions about individual things that you didn't understood, so let's wait. It is taking quite a lot of time. I think when I tested this function, it took me around like 1 to 2 minutes, so hopefully it should work. Loading is loading. Let's see. Why does this take so much time? Wait. CSV raw data. Let's try to understand if we made any mistake in the code. So this is our bucket name. This is raw JSON data, which is stored onto the raw JSON. Okay, this makes sense. Still executing. Wait. Online retail JSON. Okay, makes sense. Read the data, process the data. Okay. I think it ran out of the memory because runtime got killed. So it didn't have the enough memory to process its data. So what we will do, we'll go back to the configuration and again we will increase the memory for around, let's say, 2024, something like this, and also increase the storage memory as 2024, and I'll save it. And let's try to run it again. Hopefully this thing runs again properly. Again, it will take 1 minute, so sorry for the delay, but this is what the usual data pipeline looks like, right? Okay, so as you can see, we got the successful code because we increased the memory and we increased the storage. And now if I go back to my raw data, CSV raw data, and if I refresh this, you will see I have one file available over here, which is the CSV file stored onto this, right? So it was pretty simple. What we did, we ran the code using this bucket, read the data and wrote that data back. If I do the test again, you will see one more file available added onto this. So let's just wait for this 5 seconds. Yeah, see, we have one more file. Again, we are processing the same data again and again, but we are writing it using the different timestamp format so that we get multiple CSV files available over here. What I can do is that now I can add a trigger on top of it. So right now we are manually updating all of this data, but on the Lambda you can have a triggers. So for this, instead of this part, I can directly get the data from here, which is event data. So event data has the information about the different events that happens on the AWS Lambda. So what it does is that it goes to the record S3 bucket and name, it gets the key. So any event that happens on the Lambda, we can easily capture using this event variable that comes into the Lambda handler. Let me just deploy this, and I'll add a trigger on top of this. So what you do is that click onto this add trigger button. Okay, go to the S3, uh, select your bucket name. So in this case, my bucket was AWS-UG demo pipeline. These are the events that you can capture. So all objects created event, deleted events, restore, all of this. So I'll go with the all objects. The prefix is the path where your raw files are stored, where you want to capture the event from. So I'll just directly do this raw JSON. Okay, acknowledge this, and I'll add the trigger. So I added the S3 trigger. So what this means is that now whenever I upload any data onto this folder, which is a raw JSON, this Lambda function will get triggered. So as per our architecture diagram, whenever we have any data available onto S3 bucket, we need to trigger this Lambda function, and it should store the data back to the S3 again. So what I'll do, I'll again upload the same data back. Uh, what it will do, it will replace the data, and this will be considered as like all object created event, where what we are doing is that we are just putting the existing data on top of the data that we have available onto the S3 bucket. This will trigger the Lambda function here, and then this will write the our data CSV file back onto the uh, S3 bucket that we cleaned, right? So the overall goal of this pipeline is that all of these data usually comes from the multiple sources automatically. Right now we are just doing this manually, but if you keep refreshing, you should be able to see the three files available, because our data just got uploaded. So this will run this pipeline in the backend, and then you will see a new data available onto the S3 bucket as per the trigger. So while this runs in the backend, you can easily track it on the CloudWatch. And till this completes, what we will do, we will go on to the next part, which is the crawler, glue catalog, and the Athena part. Okay, so what I'll do, I'll just go to the glue. All you have to just write glue, open it into the new tab, and it is pretty simple. Let's just see if this got any new file or not. uh, uh, let's wait for this. Okay, till that runs, we'll go here and we'll go to the glue. Again, this is what the glue console looks like. What you need to do, you need to click on the left crawler. You can create the multiple crawlers here. You can see I have like multiple crawlers available. Click on the create crawler, give the name as AWS UG glue crawler. Okay, something like this. Click on to next. Here I need to add a data source. So click onto the data source where our data is stored. It is stored onto S3 bucket. Select the S3 bucket. So AWS UG. This is my S3 bucket. I'll select this. Okay, in this, where my transformation files are stored, so I'll go here, CSV raw data, and I'll put it over here, the path till where I need to like execute my Athena queries. Click onto the add source, click onto the next. You can choose the IAM role for the glue. Again, I have created the IAM role for the glue is this one, which is the previous for the previous project. Click on the next. You can create the database. I'll just add a new database as retail. Okay, and I'll click on the create database where all of my retail data will get stored. And if you refresh this, you should be able to see the retail. Click on to next. Everything looks good. Click on to crawler. Again, there are some advanced settings that you can go through it, but for now I just want to show you the basic glue table. Click on to run crawler. This is starting a crawler. So what it will do, it will go to all of these files available onto the CSV raw data. Okay, it will scan all of these files onto the S3 bucket, and it will create the glue table on top of it. So you can see this thing running over here. So it is currently running. It will take around 1 minute to run this entire thing, and it will add a table onto Amazon Athena. So let's just wait for this crawler to run. Again, this crawler will also create the schema tables over here. So if I do the retail, once we have our table available, you will be able to see the entire information about the uh, table. We just get the retail. Wait, yeah, this is the crawler that is currently running. Let's just wait for this to complete, and once it's complete, we should be able to see our table onto Athena. So I'll just open it onto the new tab. Okay, over here, this is AWS catalog retail, and currently we see the zero tables, but once this crawler finishes, and if it is successful, we should be able to see a table that is added on uh, the onto the blue crawler. Okay, let's just wait for this to finish. It will take some minutes, but if you have any questions, you can definitely ask me. I'll help you out. Okay, again, quite complicated if you are looking at all of these things for the first time, because you are like configuring multiple things onto the multiple services just to build a one single pipeline. I think that Lambda thing didn't work. The S3 trigger might have to check it again and see what got failed. You can also, if the logs are available, you can also track it on the CloudWatch and see if there was any error or not. But we'll skip that for now, and let's see our group crawler is running, still running stage. Hopefully this runs and we should be able to see the final output. Let's wait. Let me know if you have any questions, and it should be good to go. But while this is running, I'll also show you that one of the test table that I created previously, which was on the default. And this is the CSV raw data that you saw, which is you can do the preview of this. And here's the actual retail data that we saw earlier, right? Invoice number, stock code, description, quantity, and all of this. So the thing that we saw here, which is the invoice number, stock code, description, and everything, now is available as a CSV file onto the S3 bucket, and I can create a Athena table on top of it to write the SQL query. So now I can directly write whatever the queries that I want, such as based on the let's say stock code. Okay, so I can write the query like uh, stock code and what is this, a quantity. From this, what I can do is that I can group by stock code, and I can get the sum of the quantity. Okay, uh, I can give the name as total quantity, and if I run this now, you can directly see the for individual stock code we have the amount of quantity available for the records, right? So this got completed. Now I can go back to the actual data, that is retail data. I can refresh this, and you will see the same exact file that was available. I can just do the preview table, and you will see the same exact output available here also. So again, this was the entire pipeline, which is we stored our data onto this S3 bucket, use the Lambda function to convert this JSON to CSV format, ran the crawler, glue catalog, and Athena queries on top of it, and we were be able to see the SQL output at the end. Why? Okay, I got to go. Why am I extracting data from Snowflake so it is stored on Athena or NS3? Can you please give me some overview? I got the project in my organization to make data pipeline through Snowflake from. So when I'm so there is one question, when I'm extracting data from Snowflake, it is stored in the Athena or in S3. It is usually, so I don't understand, but when you're extracting data from Snowflake, you usually store it onto S3. Okay. Uh, so as you're saying through Snowflake to SSTPC, make data into Snowflake. So you are using Snowflake as a data source, and then you're trying to extract data from the Snowflake, right? So when you try to extract data from the Snowflake, you should put it onto the S3. Okay, and then using Lua Lambda, is there any Oreo? Yeah, so you can. I think you can use. There might be any connections. You have to build a connection with the Snowflake and extract the data. See if the AWS DMS also provides this service where you can make the connection with the Snowflake. But it is basically you just extract the data, put it onto S3 on the incremental basis, and then you process your data as per the need. So you have to design the architecture as per like if we were to extract data from Snowflake, there might be backup going on, or you write the manual queries inside the Python code or the Spark code, load data on the daily basis till there is a requirement, and once that is done, you process your data as per your need and then move forward. So I think you can do that using that. You will have to research a little bit on top of it, but this is what the pipeline should be. Yeah. Let me know if you have any other questions. Okay. So yeah, I think this was it. There's nothing else. Very basic pipeline. If you want to learn more about this, definitely I have like uh, YouTube channel filled with multiple projects. You can also subscribe to the AWS data group. We will be doing a lot of stuff onto the data engineering side, data side, AI, like overall data. We'll try to cover overall data stuff. So you can definitely check that out. And yeah, this is everything. If you have any questions, connect me on LinkedIn. You can just search my name. I'll try to help you out, whatever the issues you have and the things that you want to understand. Yeah, that's everything from my side. I hope this was insightful session. You learned something. This was everything from me. Thank you for watching. Yeah, over to you.
Yeah, thanks, Darshil. This was really wonderful. I know the audience are pretty much excited, and they do have a couple of interesting questions for the session. So let me switch on to the questions. Absolutely, Darshil already answered a few of them. Uh, so first of all, is this record session is recorded? Absolutely, the session is recorded. I'll also give the link where you can view the session. So don't worry, in case if you're joining late, we'll share this recording with you guys. The next one is why do we need Amazon Glue? Dashil, this is for you.
Okay, okay. Why do I need Amazon Glue? I mean, see, Amazon Glue is so there are multiple services available, but we have the EMR where you have to create the entire infrastructure. Glue also EMR serverless if you don't want to do that, but Glue is a service where they provide you a lot of things at one end. You can create the workflows, you can write SQL script, you can scale your Apache Spark jobs and the Python jobs as per your requirement. You can manage your data at one place. You can create the crawler. So Glue is a center of the service in AWS where you can connect to the multiple sources, do all of the processing at one place, manage your data, do the data governance with the multiple services, and then write your data. So again, this is one of the fastest way you can start building your pipeline, where you just need to focus on writing the code and everything else will be managed by AWS itself. So I think that is the reason you usually use Glue.
The next question is, can we transform JSON to Parquet? Is it more optimized?
Definitely, right? So in this demo, I was going to do that, but I ran out of time. But you can go with the JSON to Parquet is the best file format when you're working with the data engineering because it is a columnar file format. So and it also stores the schema information and the metadata. So as per your requirement, you can easily analyze on. It is also optimized for the Redshift. You can also compress it as per your requirement. So definitely uh, instead of using CSV or any other file format for the data storage purposes, you should always go with the Parquet file format. For the demo, I just tried to keep it simple so that people who are just starting out can understand.
Next question is, why we need Glue Crawler as well? This is from Bhan.
So yeah, so Groove Crawler, right? So again, you don't really need it. It is automated version of creating a table. So what you can do? Let's say if you have data stored onto S3, and there is a way you can load your data onto Amazon Redshift, where you have to do some processing and then load your data into structured format. But in data engineering, we have something called as a data lake, where what you do is that you put every single file directly onto S3 as it is. Okay, you don't do anything. And as per your requirement, use the SQL queries to do the transformation. Now, when you want to run the queries on top of these S3 files, you need some mechanism to build a table. So you can use the create table statement and provide the path to the S3 buckets and everything, files and schema and everything to create it. You can just Google it and you will find the information about that onto the documentation, how you can create the manual file. But this will require you to understand every single thing, right? You will have to understand about the column name, the schema, where it is stored, there is also called as Serde, serializing and deserializing. All of these things you have to provide it. A glue crawler automates everything for you, right? You don't have to worry about everything. So whenever you add new file, whenever you want to transform anything onto the Athena level, you can easily do that using glue crawler. So it's kind of like the automated version where you don't have to worry about building tables by yourself.
The next question is, I want to understand how to get an entry level job in data engineering.
So getting an entry level job is quite tricky because you need to show an experience in data engineering. You do need an experience. There are some things you can work on and also get internships. So instead of focusing on just job, if you try to see some good projects to work on that can build your portfolio, that's a good way to go. So what you do is that you start building your own projects. What you do, start with the freely available projects on the YouTube and try to see how you can build your own unique project with your own problems. So let's say you understand football, you have interest in football, you try to find a good data set for the football which is quite large, or APIs and everything. You integrate that data into your system, build a hypothetical scenario where you can do the transformation and try to solve a particular problem, and build your entire data pipeline project. Now in this pipeline you can include the services as per your target job. So let's say if you want to get a job around AWS data engineering services, right, you can try to utilize EMR, AWS Glue, Athena. You can also add like some third parties such as Snowflake tools for data warehousing and everything, right? So these are all of the partners that work with the cloud providers. So you can choose to build your own projects, build your portfolio, stay active in the community, like interact with the different people, follow the influencer if you want to learn something, and you can apply for the jobs. Because when you go for the interviews you need to tell a story, right? You can't just say you have done this certification. You need to tell them what you have done in data engineering till now, and having a good project is the way to go. You can also prepare for the certification if you want to stand out from the crowd. And if you don't get the data engineering job, try for the internships. If you don't get that, data analyst is a good gateway to data engineering, so you can also go for that.
Thank you so much, Darshil. The another one is from DG Booth. We have to connect Glue to Athena, or is it by default connected?
So whenever you create run a glue crawler, it creates a data catalog, right? And whenever you write Athena query, it queries using that data catalog. So you don't have to do any connection. It is by default connected.
Got it. Thank you. Next question is, in relational database, we create tables from CSV, but in here in the demo, we didn't do that. Any reason why?
Create table from CSV variable. I So again we created the table, but the you need to understand the concept of building a data lake and the ad hoc query interface like Presto and Athena, right? This is different from the relational database. Relational database are more structured, that works on the asset properties that requires you to update and insert file in the certain ways. Right? It needs to be in the proper format. Here it is just a clean file, right? It's consider it like the your files are stored onto S3 bucket, and on top of this there is a layer of glue catalog and crawler that can help you to directly query on top of the file system, which is the actual CSV file. When we ran the Athena queries, we ran the queries on top of the S3 files. We did not store that data back onto the relational database. So you can read about the open table formats, which is the better version of this, where you can understand how you can uh, build a data lake or the delta lake on top of the files that are stored onto the raw object storage rather than storing onto the relational database or the data warehouse. So it's a different concept. If you try to understand this new technology, you will understand it.
Cool. The next question is from Nalit. What could be the best format to store the ingested data in data lake? Should we use open table format like Iceberg Hoodie or Parquet ORC Avro?
I think the best file format, if you are talking about, it's always a Parquet. Okay, usually it's a go-to file format. Using the open table system again comes with a is so understand, right? Delta Lake in itself is a technology, like how it works, but there are multiple companies or the open source team that provides it. Say that you talked about Iceberg Hoodie. Uh, Individual might have like individual way of processing and uh, gives you the different features, but fundamentally it is same, right? It is just basically give you the asset kind of properties on top of your existing file system, so that you can directly write the queries on top of it. So you can just research about it. But if you're talking about the file format, it's usually Parquet file format, okay. And the open table format, if you're talking about, you'll have to do your own research and see what fits best for your use case.
Next question is when to use Parquet versus when to use ORC.
So usually, I mean, ORCs, I think, as I remember, I haven't really worked on ORC, but it is a row based format, right? If I'm not wrong. Parquet is a column based format. So, answer, I think it is pretty simple. If you want to have a data stored onto the row level, uh, for the relational databases, I think you can go with the ORC. I'm still not sure about this answer because I haven't really explored the ORC file format. But again, you should use Parquet when you have like a lot of columns and for the analysis. So I think just Google it, you'll find the answer. Yeah.
Cool. Where can we get the basic data engineering project to start with?
Uh, Data engineering projects. I mean, my YouTube channel is freely available. I have around like 8 to 10 free projects available. You can start with. On Data Vidya also we have some courses available on projects, so you can also do that. But all you need to do is either go on to GitHub or freely available. Just Google it, right? Data engineering projects. You will find bunch of resources. This question can be easily answered if you just Google it. So I don't think you need anything else for this.
Makes sense. I think Shubham has a couple of questions and he was looking around. Is there any specific video or to deep dive understanding about AWS Glue from you?
AWS to Glue. Wait.
Is there any deep dive video understanding about AWS Glue from your end?
So there is a one project available on my channel called as a YouTube data analysis. Okay, that you can watch out. It was like 2 years old, but I think that will give you the good fundamentals. Uh, yeah, I think that should be it. And just YouTube it. I mean, you'll definitely find it on the docs also and the YouTube also. You'll find good resources.
Makes sense. Uh, Last question is this schema on read or schema on write from Banu? I think it is around Glue.
It is schema on read, right? So that's a good question, right? Because that's the difference between relational database and the normal, right? Relational database is schema on write, because when you're writing this, you provide the schema, and based on that, you do all of your things. But when you read data from the data delta lake, okay, it is schema on read. While you're reading the data, you're providing the schema and then making sense out of it. So yeah, it's a schema on read.
Yeah.
All right.
Yep. Next question is Snowflake better or Amazon Redshift?
uh Again, these are two different things. Everything has its own use case. Snowflake was started as a like core data warehouse platform, but now they are full-fledged database ecosystem, right? You can also build your application on top of it. You can write SQL queries, Python code. They have like what do you call it, Snowpark, if you want to do some transformation. So both has like different use cases in this. Amazon Redshift is like the solid data warehouse ecosystem that's been like running from last like 10 to 15 years. Okay, Snowflake is a modern database tool that you can use to run different workloads for your organization. So again, this technological decisions usually comes from the requirements, like do we want to go from outside our cloud platform and attach the external tool? If we were to go that, what is the cost, what is the optimization, how do we scale, how do we manage data? All of these things are taken into the consideration. So you cannot say like, okay, this one is better, this one is better. You should always answer from what is the use case, and then how do I make this better for myself, like that.
Makes sense. There are a couple of more questions. How to handle schema changes in Glue?
You have to run the group crawler again if you want to. I think there is an option to replace the schema, so you'll have to run the group crawler. If there is no schema change, then you can automatically store the files and query it. But I think you have to run the crawler.
Cool. I think that's pretty much what we have. Absolutely. There are a couple of more questions and we'll ask them offline. But
Okay.
thank you so much, Darshil. I know you have answered so many questions, so I just want to be cognizant of your time and energy as well. So
Thank you so
thank
much.
you so much, everyone, for joining. Absolutely, there are a couple of questions which we are skipping for now in terms of like AWS Glue and Lambda can run in free tier and all. Lambda, absolutely, there are certain time limits you can run in free tier. Glue, you can check the AWS free tier page. We'll get the understanding and detail, what services, how much it can run, and other stuff. So please look into the pricing page of that one, and if not, then do reach out to us. We'll share the link with you. So thank you so much, Darshil, again. With that, let me go ahead with the next part of our today's session. What next? I mean, I know you, everyone liked the session so much, and I can see that interactive audience, and as well as other audience online, right, which are learning from it. So, what is next after this? Absolutely, this is a journey what we have started to learn and to evolve, right? So, the next interesting is going to be an Amazon QuickSight Bootcamp. This is bootcamp is going to be spread across weekends, running across different sessions, and these sessions will try to cover up four different sessions we are going to have and cover different topics, which will be hosted. And the speaker for the session is going to be some AWS experts itself in Amazon QuickSight, which is going to help you to learn from scratch. So, in case if you don't know what is QuickSight, you just know you have the sample data and you want to learn from QuickSight right from A to Z. You want to become from zero to hero. Then this is exactly the bootcamp. We already have the registration page here. Scan the barcode, or you already have the link here. I'll put in the chat as well as. So please do register today, and we can keep you posted how exactly that session is rolling around. This mostly is going to be in timeline of June. We are still working around on the logistic part of it, so stay tuned. But please can register today, so this can help you. I know people are looking around. Can you put the link in the chat? Just give me a minute. I'll do it right away for the folks. So I've put it in the chat as well as for the link to register for it. And I've also put the link for us to follow the Data User Group India. So this is just a start. A lot of things going to happen with us. So stay tuned, follow us, and stay safe. So with that, we'll take an exit from today's session and keep following us. That's look in the next session. So with that, thank you so much. I'll see you guys in the next session. Thank you. And thanks, Darshil.
Thank you, everyone. Yeah.
Okay.